Hey everyone, welcome back to another episode of the Weekly Coder. I'm Chris, and today what we're going to talk about is how we can add a feature to our Tetris clone, and that feature is going to be the ability to save Tetrominos and then swap them back and forth between the current and the current falling one and the one that we're saving. So adding this functionality is actually quite simple. So I apologize in advance. I've got a ton of notes on my other monitor here, so you're gonna see me do this a lot. So just for reference here. Well, let's start simply here. We gotta do a couple of things to prepare for this feature that we're gonna add. First thing we got to do is we got to create two tags, okay? And these two tags that we're going to create, they are going to be assigned through code to our Tetrominos at any given time. And the tags are going to be the current active Tetromino and the current saved Tetromino, so that at any time during the game, we can easily grab either one of those, okay? So that when we press our button to save a Tetromino, it gets tagged with, okay, you're now the saved Tetromino, and the current falling Tetromino is tagged with the current falling Tetromino tag. And then once a Tetromino lands, we just set its tag to untagged, so that, there are only ever two pieces in the game with a tag. So here's what we do. We can go up to Edit and Project Settings, and then go to Tags and Layers. Go ahead and expand tags, and we've got an empty list of tags right now, which is fine. So we're gonna add the first one. We're gonna just call it current active Tetromino, and then we add another, and we'll call this one current saved Tetromino. And keep in mind that when we call these later to assign them to the Tetromino, or to find the Tetromino by the tag, then we have to make sure that we use the same case, because these are case sensitive. So here I used a little C, a big S, a big T. So I'm gonna have to make sure that I follow that convention there, and this is how I type. So you guys can name them whatever you want. Just make sure that you know what they're for. All right, so we're done with the tags. The very next thing we got to do is actually we're gonna jump right into our code. So let's open up the game class. Actually, before we do anything else, let's go into our Tetromino class, and in our move down method, okay, where either the player moves the Tetromino down, right? Yep. Or the game moves the Tetromino down. At some point, the Tetromino lands, and we set its enabled property to false. Now that we're also dealing with tags, we're going to want to set that to be untagged, because when this one is set to false, okay, when it's no longer enabled, then we also spawn our next Tetromino. And then our next Tetromino we're going to tag with the tag current active Tetromino. If we had two current active Tetrominos, then we would end up having a problem when we did our swaps. And so let's make sure we do it right. Okay, so let's not forget this. We're going to go ahead and set the tag here equal to untagged. Okay, just like that. And that is actually all I think we're going to need to do in our Tetromino class. So over in our game class, we're going to create a couple of variables. And that is going to be actually, okay, so you see here how we've got our preview Tetromino position. As you'll remember, if you can, because this was like a long time ago that we've done this now, this actual position is used to reference, as a reference when we instantiate our next preview Tetromino, and we use this preview Tetromino position variable, or vector2 variable, to basically assign the position of our preview Tetromino, so that we don't have to remember these numbers every time we want to assign it. So we just store them in a variable. We're going to do the same thing for our saved Tetromino, you know, the on hold one. So we're going to call this saved Tetromino position, and it's going to be a vector2 as well. And let's go ahead and put it in the same x position, negative 6.5f. But as far as the y position, let's go with 10. Okay, so that should put it like right underneath the other one. Okay. So what else do we need? We're gonna need a game object. Okay, because we've got a game object for preview Tetromino, we've got a game object for next Tetromino, and now we're going to need a game object that is going to be our save Tetromino. Okay. Tetromino, right? So yeah. All right. So now, what we want to do is we want to impose a constraint to the player to only allow them to swap out their Tetromino a specified number of times. So you don't want them to constantly be swapping back and forth with the piece, because that would give them a cheat, which is to just kind of put the game on hold and look at the screen and try to decide where to put that piece. So in essence, you would allow them to pause the game indefinitely by just pressing the button back and forth. So we don't want to do that. We want to set a maximum number of swaps that is allowed between the pieces. So, and the way we do that is, of course, we're going to add some variables. So we're going to make this one public, and we're going to call it max swaps. And initially, we'll just go ahead and set this to 2. And the reason that we're making it public, of course, is because we want to be able to edit this value in the inspector, so that, you know, we can fine tune it if we want to go with 5 swaps, 1 swap, 3, 4, whatever. That way we have an easy way to actually adjust that variable. And then we need to keep track of how many swaps have actually happened. So I'm going to call this current swaps. I'm going to set that to 0 initially. Okay. So that should be pretty much all the variables we're going to need. Okay, so let's go ahead and jump down a couple of lines right about here, right above the check is above grid method. We are going to create a new method, and it really doesn't have a whole lot to do with saving a Tetromino or anything like that. This is more of a convenience kind of method that we're going to use to validate that we are at a proper position for when we instantiate our Tetromino from its swap position to its new position. So we're just going to use this to verify that it's a good point. So we're going to call this, we're going to make it a bool. It's going to return true or false. So we're going to do check is valid position. Okay? And we're going to pass in a game object of Tetromino. Actually, we're going to pass in the Tetromino game object. Okay? So we're going to do a for each loop, and we're going to get the transform, and we're going to save that in Mino, and we're going to get a transform in every Tetromino transform. Okay? And then for every one of those, we are going to get a reference to the position, the rounded position, by the way. So that's Mino position. And then we're going to check our check is inside grid. And we're going to pass in position. Oops, we don't actually need. Okay. And we're going to return false for that, okay? Because if it's not in the grid, then we want to return false because the position obviously isn't valid. So then we're going to check also if we're going to use our get transform at grid position method and pass in the position. Make sure that doesn't equal null. And then we also are going to get the transform grid position of parent. Double check and make sure that that doesn't equal the transform of the Tetromino. Oops, don't need that. And we will also return false because that's obviously not a proper, a valid position either. Okay, so otherwise, if we make it through this entire for each loop without returning false, we then want to return true because we are obviously at a good position. Okay, so and you'll see this method we're going to use pretty soon here in the next method that we're going to make. I think we're going to use it. Yeah. Actually, let's go ahead and jump into our spawn next Tetromino method here. And for these, we're going to go ahead and tag our next Tetromino game object. Okay, I'm going to set next Tetromino dot tag. We're going to set that equal to current active Tetromino. And the same thing down here. Next Tetromino dot tag current active Tetromino. Alright, and then also when we spawn our next Tetromino, we can go ahead and set our current swaps. Oops, that's our swaps. We can go ahead and set our current swaps to 0. Yeah, exactly. We can set our current swaps to 0 here because when we spawn our next Tetromino, we're getting a new piece, so we want our current swaps to basically be reset so that we have another 2 or 3 or 4, however many our max is, to swap our piece back and forth. Alright, so with that out of the way, I think what we'll do next is we're going to create our... Let's go ahead and create the method that we're going to use to save our Tetromino. So let's go down here. I'm going to do public void save Tetromino. And we're going to pass in the transform of the Tetromino that we want to save. Okay. And the first thing we want to do, if we call this method, we're obviously going to swap or save. Well, swap. Yeah, we're swapping for a new piece or for a piece that's currently being held. So let's go ahead and increment our current swaps by 1. And then let's check what our current swaps are. So if our current swaps are greater than our max swaps, then we want to return, because we don't want to continue to be able to do anything with this method because we've already exceeded the amount of times that we want to allow the user to swap. Okay. So next thing, we need to actually check to see if there currently is a Tetromino in the saved location, like in the saved spot. So we basically do if saved Tetromino doesn't equal null, okay, then that means that there is currently a Tetromino being held. Otherwise, there is currently no Tetromino being held. So and this is important because we need to know if we're going to do a swap with the current piece that's falling and the piece that's being held, or if we're going to just hold the piece that's falling and then wait for the new piece to fall, right? So two different scenarios here. Now, if there already is a Tetromino being held, that means we actually have to take that Tetromino, we have to store it in a temporary game object, we then have to take the current Tetromino that's falling, we have to store it in the saved Tetromino location, then we have to take our temporary game object and we have to set it to our current falling Tetromino. Alright, you guys still with me? Let's get to the code. So we're going to create our temporary game object first. Okay? So we're going to do game object, temp save Tetromino. And we're going to, here we're going to use game object.find game object with tag. And we're going to find our current saved Tetromino. Okay? So basically, we're getting a reference. We're creating a game object and we're using it as a reference to our current saved Tetromino game object. So then we're going to set the position of our temp save Tetromino, right? The transform.local position. Yep, position. We're going to set its position to a new vector 2, the grid width divided by 2, and grid height. Because basically we want to put it in the middle of the grid, but at the height of the grid so it falls from the top. There was a time where I was playing with the idea of actually swapping the pieces where the current piece is already falling. But I didn't think that that was fair enough to the player. I thought that that made the game a little too difficult because you would have your piece and at some point you wouldn't be able to swap because your piece would be in a place where it wouldn't fit, so then you're stuck with the piece you're at thinking that you're going to have time to swap the other piece out, and it was just a big mess. So this is how I prefer to do it. You guys, if you want, you can actually just, all you got to do is get the position of the current active Tetromino and just set the position of the temp save Tetromino to that, because this is eventually going to become our new active Tetromino. Anyways, enough rambling on. Let's get on with it. So here we're going to do, and this is where this method actually is going to come in more handy, because right here, for the most part, we're going to know this is a valid position because we're putting it in a valid position. So this is probably not even needed with what I'm doing here, but feel free to use this when you're, if you're trying to, get the position of the current active Tetromino and putting the saved Tetromino in that position instead. So basically you're swapping out the pieces at the actual location of where they were. So there. And then we return. So basically, if we're not in a valid position, then we save our, we set our, God, I can't speak. If we're not in a valid position, then the local position of the temp save Tetromino is basically set at the position of our save Tetromino position, the one that we set in the beginning, the variable, and then we just simply return because there's nothing else for us to do. Okay? So let's say we make it past this condition here. everything looks good, so let's go ahead and do the swap. So we do save Tetromino. We're going to instantiate our save Tetromino game object with the transform, or the game object of the transform, the game object of the transform that we passed in. Okay. So that is basically what we're gonna, when we call this method, we're going to pass it the current active Tetromino, because that's the one we want to save. So then we do save Tetromino. We're going to get component, and we're going to get the Tetromino component, and we're going to set the enable property to false, because that piece is now being saved, so it should stop moving and it should not be responsive or respond to any kind of user input or anything whatsoever. So then we've got save Tetromino transform local position, and we're going to set that to new vector 2, and we're just simply going to use, again, grid width divided by 2 and grid height. And here comes the important part. We're going to set the tag. Save Tetromino.tag equals current saved Tetromino. Alright. So now we've got our Tetromino saved, and now what we need to do is we need to instantiate our next Tetromino with our temporary saved Tetromino, which used to be our saved Tetromino. So we're going to do next Tetromino equals game object. So I'm casting game object to instantiate. And we're going to use temp saved Tetromino. That's what we're going to use to instantiate our next Tetromino game object. And then we're going to set the enabled property of next Tetromino to true. Alright, so now we need to also set its local position. Yep, here. This is going to equal, let's cut that, saved Tetromino position, because we're saving that piece. This one, however, is going to be the grid width divided by 2 and the grid height. Okay, so we've got that, and then all we got to do is we have to tag it. Oops. Tag current active Tetromino. Okay. So now that we've got these, we don't need the temp anymore. And we don't need the game object of the transform that we passed in. So let's go ahead and destroy those. And we want to destroy immediate so that they get destroyed in the frame that we're in. T.gameObject and destroy immediate temp save Tetromino. Alright, so now this is for a swap. If we have to do a hold because we don't have a piece in the holding chamber yet, then all we need to do here really is we need to instantiate the saved Tetromino game object with our current active Tetromino game object, and then we have to spawn a new piece. Simple enough. So let's do that. Save Tetromino equals game object, instantiate, and we're going to instantiate it with game object, find game object with tag, current active Tetromino. Alright, and save Tetromino transform. Let's do this. Get component. Tetromino. Now set its enabled property to false. And hang on, I made a mistake here. Save Tetromino. Transform dot local position equals saved Tetromino position. And what else? Oh yeah, we got a tag. Saved Tetromino dot tag equals current saved Tetromino. Okay. And we're going to go ahead and destroy immediate. We're going to destroy the current active Tetromino. So game object, oops, dot find object with tag. Current active Tetromino. Okay, because when we instantiate a new Tetromino, we don't want to have two current active Tetrominos, right? So then all we need to do is we need to call spawn next Tetromino, and that's it. That is our whole save Tetromino method, and that's really all we got to do to that one. We've already added the tags here. I think the only thing actually left to do, yep, one more thing to do. We got to go into user input, which has got to be somewhere up here. Okay, here. And we'll just do if input get key up key code dot space. Alright, so spacebar is going to initiate the swap, and for our swap we're going to first create a temporary game object. Yep, we're going to instantiate, or not instantiate, we're just going to reference a game object, so temp next Tetromino, which is actually our current Tetromino, so that's going to equal the game object find object with tag, oops, current active Tetromino, and then we are going to call our save Tetromino method, and we're going to pass in our temp next Tetromino transform. And that should be it. We should be good to go. Can't think of anything I could have missed. That's possible though. So let's try this out. We have a compiler error. Okay. Okay, apparently I'm doing something wrong here. Checking my notes. Oh my gosh. Why didn't I see this? And you guys didn't say anything. I can't just say false. That actually, we're supposed to return false. Oh, that was so horrible. Okay. currently started in the game over scene. Let's go to game menu. Let's click play, and we're gonna press spacebar. All right. So now we've got our square. We've got our T in the holding position. So we want to swap the two. All right. So now we've got our T and we've got our square in the holding position. Swap them. All right. Let's try to swap one more time, and we can't because we've exceeded our swaps. Okay, so let's go ahead and put this piece down. Oh, okay. So we want to save this guy because he's important. So we're gonna save this one, and let's go ahead and build our set ourselves up for a Tetris. Oh, getting lots of long pieces here. Holy. Okay, let's use this one. And let's swap back because now we can actually use our long piece. There we go. And everything is working perfectly. Okay guys, so that's pretty much it for this tutorial. If there's any questions, feel free to, like always, comment down below. Don't forget to like the video on the channel, subscribe, get other people involved, tell other people about the channel, and feel free to send in, keep the requests coming, and I'll continue to create content for you guys, alright? Have a good weekend, and I will see you guys next time.